Hello, yung Spot. I'm George. Welcome to a new episode on this series on load balancer infrastructure, and today I will be exploring an extra layer of protection on my load balancer using authentication on OpenID Connect. And so if this series and the content of this channel lines up with your interests, hit the subscribe button and join me in this journey of learning by doing. So, let's start coding. In today's episode, I will explore the implementation of a listener rule that calls an authentication mechanism before I allow access to an application that is behind my application load balancer. So I am going to add another layer of security to the Nginx application that I have associated with my application load balancer. In one of the episodes on this series, I have set up my Nginx application to be behind an application load balancer. And this has been set up with TLS or HTTPS to enforce a secure way of accessing the endpoint. I am going to add another layer of security and protection by enforcing a user authentication when someone attempts to hit the Nginx endpoint. And I'm going to do this through my application load balancer using OIDC. So what is OIDC? It stands for OpenID Connect, and it is a protocol used to authenticate and verify the identity of a user when accessing an endpoint that is protected with TLS. And so in today's implementation, I am going to leverage on OKTA to do the actual authentication for me. So this is the flow that I expect to happen once all the necessary infrastructure resources have been stood up successfully. A user will attempt to access my application endpoint, and behind the scenes, my application load balancer will be hit and my OpenID Connect listener will be triggered. The load balancer will determine if the user has been properly authenticated and will render the appropriate login page to the user. The user will then authenticate, and if it's successful, my identity provider, which in this exercise is OKTA, will determine if the user that has successfully logged in has the right permission to access my web application. If the user is not authorized, a 401 message will be rendered on the page, and if the user is authorized, the actual web application page will be rendered. So let's start the actual work. There are two different sets of infrastructure that I need to set up today, and one set is for my OKTA infrastructure, and another set for the authentication block that I need to configure on my load balancer listener. I am going to start with the OKTA infrastructure. Note that OKTA is a different service provider from AWS, and it has its own set of infrastructure API endpoints on its own. And so the first thing that I need to do is update my backend.tf. I am going to add a new block inside the Terraform block to pull in the provider definition for OKTA. This code block is equivalent to telling my Terraform CLI to download all the necessary libraries that I need to be able to call OKTA API endpoints and be able to create resources inside my OKTA account. And in order for my CLI commands to be able to integrate with OKTA API endpoints, I need to update my providers. So let me open my providers.tf. And then add a new block for OKTA provider along with the necessary information that I need to be able to make API calls. I have all of these values stored in my SSM parameter in AWS. And so what I need to do is head to my data.tf, and then all the way to the end of this file, I am going to define data blocks to fetch the relevant Okta values I need to set up my provider. So I'll start with my Okta base URL. And then my Okta org name. So I'm just going to duplicate this block. And then my Okta token. My Okta token is an encrypted string, so I will need to add a new property in this block called with decryption and set the value to true. If you want to get an understanding of how I ended up with these values, you can head to this series right here, where I covered setup for AWS single sign-on with Okta. And now that I have data references for my Okta parameters, let me head back to my providers.tf and update the properties accordingly. This should now allow me to make API calls to Okta and create resources when I run my Terraform commands. Now, let me head to my main.tf. And at the end of this file, I will start creating a new resource block that will allow me to create a new Okta authentication application that I will use for the integration with my load balancer. Let's start filling up the properties for this resource, starting with the basic label property. I am also going to add type property and set this to web. This indicates the type of my OAuth application, which in my case is a web application. I am also going to add grant types property, which accepts a list for a value. And because I'm using this Okta app for my web application, I will add authorization code in the list. And to supplement this grant types property, I will add another property called response types, which also accepts a list. And then I will add code in the list. For security reasons, I'm also going to add another property called omit secret and set this to false. What this will do is exclude the client secret from being persisted in my Terraform state file when I start standing up my Okta resources. The next property that I need to set is the redirect URLs property, which also accepts a list. This property defines a list of URIs that the user will be redirected to after a successful authentication and authorization through Okta. I am going to add my Nginx endpoint in this list, which is what I will configure for authentication later on. I will set the URL to contain the appropriate IDP response URL for this to work. And so what I will do is add my Nginx URL. And then append a IDP response route at the end of this URL. So that is my Okta application that will handle the authentication and authorization for access to my web application. What I need to do now is configure a listener rule that will integrate with this Okta application. So let me head to the code block that contains my listener rule for my Nginx web application. Which is right here. What I'm trying to achieve with the additional configuration inside this resource that I am going to set up is that I want the user's identity to be verified before allowing access to my Nginx endpoint. And so inside this listener rule resource, I will add a new action block. And inside this action block, I will add a type property. So far, I have used 3 different types with my load balancer listener setup. I have used redirect to make my load balancer handle redirection to another website, which in my case is google.com. I have used forward to make my load balancer forward a web request to a web application that is running on an EC2 instance and a Lambda function. And I've also used fixed response to make my load balancer send a fixed response back to the requester. Today, I will be using a new action type. I will be using Authenticate OIDC to force user identity verification. This action type will need the Authenticate OIDC block. The first property that I need to set inside this block is the authorization endpoint. This will need to point to my Okta authorization endpoint, which usually starts with my Okta base URL and a route that points to an OAuth endpoint. Notice that I'm using a local parameter to reference my Okta URL. This means I have to head to my locals.tf and define this. I will define a new local parameter called Okta_URL. Which will be a HTTPS endpoint that is a concatenated string composed of my Okta org name and my Okta base URL. I already have these defined in my data references to AWS SSM parameters, so all I have to do is build this into a string. And now that I have my Okta URL local parameter defined, let me head back to my main.tf. Inside the Authenticate OIDC block, I also need to add the token endpoint property. And I need to set the value for this property to point to the appropriate token route on my OKTA URL. I need the user info endpoint and also point that to the appropriate OAuth user info route on my OKTA URL. And then I need to define an issuer property which I will set to point to my OKTA URL. And then I will define two session-related properties. The session cookie name, which is an arbitrary string that identifies the session, and a session timeout. The next set of properties that I need to define include the scope property, which I am going to set to OpenID profile. This defines the parameters specific to a user that will be requested from the IDP, which in my case is OKTA. I also need to add on unauthorized request property and set the value to authenticate. So what this property does is, if the user is not authenticated, it will force an authentication process. And the last two set of properties that I need to define are specific to the OKTA application that I have set up earlier. In order for my load balancer to know which OKTA application to integrate with, I will need to define the client ID and the client secret properties. I will set the client ID to a reference to my OKTA app client ID. And I will set the client secret to a reference to my OKTA app client secret. Now, let me head to my VS Code terminal and start updating my infrastructure. So in here, I will export my TF workspace environment variable as usual. And then set my AWS credentials using AWS Vault. And then run Terraform init. Terraform plan. And then Terraform apply. And with my infrastructure now updated, let me switch to my browser. I have set up my browser to be in incognito to have a fresh set of session. And so what I'm going to do next is attempt to access my Nginx endpoint. Notice that I am being redirected to OKTA to authenticate, which means my load balancer configuration is working. I am forcing a user to log into an IDP before accessing my Nginx website, which is an added security layer for my infrastructure. But you will notice something even more interesting. So if I go ahead and log in with a valid OKTA account, notice that I'm getting a 401 response on this page. This is because my OKTA account has not been configured yet to be able to access the OKTA application that I created earlier. This becomes my second layer of protection on accessing my web application. What I need to do to set my permission is to update my infrastructure code and assign the appropriate permission to a group in my OKTA account. So let me head back to my code. And then head to my data.tf. And then in here, I will define a data reference to an existing OKTA group. I have an OKTA group called developer that I want to grant permission to this OKTA application. So I will add a property called name and set this to that value. I am part of this OKTA group, so technically, once all of these are set, I should be able to access the Nginx endpoint. And so let me head to my main.tf, and then at the end of this file, I will create a new OKTA app group assignment resource to link my new OAuth app and the OKTA group reference that I have just set. On this new resource, I will set the app ID property, which I will point to my OKTA app. And then I will add a group ID property, which I will point to the data reference that I've set for my OKTA group. And now onto my VS Code terminal, and then update my infrastructure. So I'll start with running Terraform plan. And then Terraform apply. So my infrastructure has been updated. Now let me switch back to my browser. Remember, I already have successfully authenticated with OKTA, so my session is already created. And so if I try to access the Nginx endpoint once again, I can now access my Nginx web application. And that's all I have for today. Stay tuned as I continue to explore better ways of implementing infrastructure code for load balancers. In the meantime, let me know your thoughts in the comments below and send me some likes if you find this useful. And don't forget to hit the subscribe button if you like the content on this channel. Until next time, keep learning and stay safe. See ya.